Hello everyone, I'm Sam. Welcome to my SPM YouTube channel. Today in this video, I'll be teaching you how to ace Euclidean geometry questions. By the way, I call this how to ace Euclidean geometry questions part 2. If you haven't seen my previous video on how to ace Euclidean geometry questions part 1, don't forget to check it out. You can't miss it. I mean, it's a crucial part of this series. There we have our question 10. Question 10. O is the center of the bigger circle. O lies on the circumference of the smaller circle. O, W, V, U are points on the circumference of the smaller circle. T, S, V, U are points on the circumference of the bigger circle. Before we jump to solve questions, let's focus on the diagram. We are given that O is the center. TV is the line that passes through the center O and connects 2 points on the circumference. So TV is the diameter of the bigger circle. And what we know about diameter is that it subtends a 90 degrees angle at the circumference. Diameter TV will subtend 90 degrees angle at angle S. We are given that angle O1 that is at the center is 2x. And if you check, angle S1 and angle O1 are subtended by TU. So angle at center will be 2 times angle at circumference. Therefore angle S1 is equals to x. We have our angle S1 as x and angle S1 plus angle S2 as 90 degrees. So angle S2 will be equal to 90 degrees minus x. Another thing, on a bigger circle, TU subtends angle S1 and angle V3. So angle V3 will be equal to x. The reason is angle on the same circle. Right now let's focus on the smaller circle. OWVU are points on the circumference of the smaller circle. So OWVU is the cyclic quad on the smaller circle. Let's highlight that. In our cyclic quad OWVU, angle W1 and angle V3 are subtended by OU. Therefore, angle W1 is equals to angle V3 is equals to x. Reason angles on the same circle or angles subtended by the same arc. Okay, we have our angle W1 as x. Let me tell you something that you learners don't take seriously. You don't take exterior angle of a triangle seriously. Just because it's a property that you learned in grade 8 or 9, it doesn't mean it's not applicable in grade 11 or 12. What I'm trying to tell you is that take exterior angle of a triangle seriously, because in most cases examiners apply it because they know that you tend to forget about it. Look at angle O1. It's the exterior angle of triangle OVU. And what do you know about exterior angle of a triangle is that it's equals to 2 opposite interior angles of a triangle. So angle O1 is equals to angle V3 plus angle U. Let's calculate angle U. 2x is equals to x plus angle U. So angle U is equals to x. I think we can now solve questions. 10.1. Name 4 other angles each equal to x with reasons. Since we discussed everything on our diagram, let's name them. Angle O1 is equals to 2 times angle S1. Reason angle at center is 2 times angle at circumference. 2x is equals to 2 times x1. Angle S1 is equals to x. Angle V3 is equals to angle S1 is equals to x. Reason angles subtended by the same arc. Inside the smaller circle, angle W1 is equals to angle V3 is equals to x. Reason angle subtended by the same arc. Angle O1 is equals to angle V3 plus angle U. Reason exterior angle of a triangle. 2x is equals to x plus angle U. Therefore, angle U is equals to x. We are done with naming other 4 angles that are equals to x. So we can move to the next question. 10.2. Determine the size of angle W2 in terms of x with reasons. Angle W2 is inside the smaller circle. So right now I need you to focus on a smaller circle only. So angle W2 is equals to angle O2. And the reason is angle subtended by the same arc. Both of them, they are subtended by a chord UV. So that's why angle W2 is equals to angle O2. If we find the size of angle O2, we'll be done with determining the size of angle W2, since angle W2 is equals to angle O2. And then let's find our angle O2. Angle O2 is equals to 180 degrees minus 2x. And the reason is angles on a straight line. Angle O2 and angle O1, they are on the same straight line and they are adjacent to each other. Since we found the size of angle O2, let's go and get our angle W2. But angle W2 is equals to angle O2, and the reason is angles subtended by the same arc. Therefore, angle W2 is equals to 180 degrees minus 2x. Yeah, we are done. You can see that it's easy to attain 4 marks on a Euclidean geometry question. Subscribe on my YouTube channel. More brainstorming techniques are coming for you. You know how to attain 6 marks on a Euclidean geometry question. Trust me, this is my thing. I know how to do this. Let's go and ace the next question. 10.3. Prove that WS is equals to WV. Let's highlight that on a diagram. WS, WV. Okay, we are done. You can see that WS and WV are on the same triangle. And the question is, what type of a triangle has two sides that are equal? It's an isosceles triangle. And what we know about isosceles triangle is that base angles of it are equal. And that applies because two sides of it are equal. Then what is the converse of that? The converse is, if two angles on a triangle are equal, two sides opposite those angles will be equal. That is what we're going to do on this question. If we prove that angle S2 is equals to angle V1, we will know that WS is equals to WV. Okay, let's show that angle S2 is equals to angle V1. We already got angle S2 as 90 degrees minus x on our diagram. That's what we done on our diagram. So we need to show how we found 90 degrees minus x. Let's get it done. Angle S1 plus angle S2 are equal to 90 degrees. Reason, angle on a semicircle. It's important to do everything step by step. In question 10.1, we proved that angle S1 is equal to x. So let's substitute it. X plus angle S2 are equal to 90 degrees. Therefore, angle S2 is equal to 90 degrees minus x. Now we need to show that angle V1 is equal to angle S2 is equal to 90 degrees minus x. So how are we going to do that? We already know that angle W2 is equal to 180 degrees minus 2x. We have proven that in question 10.2. Another thing about angle W2 is that it is the exterior angle of triangle WSV. And what you know about exterior angle of a triangle is that it's equal to two opposite interior angles of a triangle. So angle W2 is equal to angle S2 plus angle V1. Let's write everything down. We start with angle W2 is equal to 180 degrees minus 2x. Proven in question 10.2. Angle W2 is equal to angle S2 plus angle V1. Reason, exterior angle of a triangle. Let's substitute everything. 180 degrees minus 2x is equal to 90 degrees minus x plus angle V1. Angle V1 is equal to 90 degrees minus x. Angle S2 is equal to 90 degrees minus x. And angle V1 is equal to 90 degrees minus x. Therefore, angle S2 is equal to angle V1. Reason, both they are equal to 90 degrees minus x. Since we have proven that angle S2 is equal to angle V1, we can conclude that WS is equal to WV. And the reason is sides up is equal to angles. That's all for today's video on Euclidean geometry. If you found this video helpful, please give it a thumbs up and subscribe to my YouTube channel for more math lessons. Your support means a lot to me, and I'd love to have you join our community of learners. Last thing, if you have any question or need further clarification, feel free to ask in the comments below. Thank you.